So for the formula of the arc length in polar, we are going to use the formula that we just deduced in parametric, and then use as we have used before that x is equal r, and remember that r depends on the angle, cosine, and y is equal r sine. And have in mind that r depends on the angle, meaning that every time that we have to do a derivative, we should write down r prime. So the derivative of this one is, this is a product, this formula here is a product, so we'll use the product rule for derivatives, and so that will be the derivative of the first one times the second one as it is, plus r times the derivative of cosine, which is minus sine. And the derivative of this will be the derivative of the first one times the second one as it is, plus the first one as it is times the derivative of the second one, which is cosine. So we have the derivatives, that is what we need in the formula of arc length. Remember that the formula of the arc length in parametrics was the integral between the two values of t of the square root of the derivative of x squared plus the derivative of y squared dt. And now we just calculated how much are these derivatives in this case, right? So in the case of polar. So we just have to put in x prime and y prime the two expressions that we deduce here. So we are going to have a gigantic expression here where we put the square of this one. So let's start. This is a subtraction, so the square is going to be the square of the first one minus the double of the first one times the second one plus the square of the second one. So this is just the square of this part here. So now plus, and now the square of y prime. That is the same thing, the square of the first one, double of the first multiplied by the second, and the square of the second. I'm going to continue the square root here, and so the radicand is going to be now r prime sine square plus 2r prime sine r cosine and plus r cosine square. So that is all what goes inside of this root. Well, you should finish these operations. Here should be a square. Are easy to see. We can see right away that there are two things that are exactly the same, adding and subtracting, right? So this and this cancel, right? So it's exactly the same expression. And so we end up with these four terms. This plus this plus this plus this, everything adding. So let's write down this in the next page. So we have the square of the first term will be r prime square cosine square plus the square of the other one is going to be r square sine square plus r prime square sine square, and the last one is going to be r square cosine square. Okay, so we can see here, continue to do the algebra, that these two terms have r prime in common. So let's put this together. So that will be r prime square times, and see that what remains here, cosine square plus sine square, is just 1. So we put just 1. And plus observe that the other ones, these two, have r squared in common, and again what remains in one and the other is sine squared plus cosine squared, so it will be r squared times 1. And so the final simplification here gives just a square root of r prime squared plus r squared. And this is the formula then for length in polars. So I repeat the formula. The length in polars would be, the length of the arc in polar would be the integral from the first angle to the second angle of the square root of the derivative of r squared plus r squared. Okay, so let's see how do we apply this formula in a concrete example. See that to calculate the arc length, you need r and you need r prime. So let's see this example. Let's calculate the arc length of this curve from this angle to this angle. We just write down the formula that we just deduced. This is the integral from 0 to pi, and so here comes the square root of r, that in this case is this, square, plus r prime, that in this case actually is the same thing, square. So this is the integral that we had to calculate. In this case it's very simple. So we had that this is the square root of 2 times this square, and the algebra here just separating the square root of each of these things. This is the integral of square root of 2 e to the theta. And so we take the number out of the integral, and the integral of this is itself. And so we just evaluate between 0 and pi. So let's evaluate, and this will be minus e to the 0, which is 1. This is the final length of this curve.